Hello students, welcome to Soros's classes. In this video, I will be solving a question from ISS 2015 paper 1. Now here we have x, a random variable x which follows f m comma n distribution where m and n are degrees of freedom. So they are degrees of freedom. So we have an x which follows f distribution with parameters m and n. So we have to obtain expectation of x raised to the power minus r. Now since x follows f distribution with parameters m and n, this implies f of x would be equals to m by n raised to the power m by 2 divided by b m by 2 comma n by 2 into x raised to the power m by 2 minus 1 divided by 1 plus m by n x raised to the power m plus n divided by 2, where this is a beta function. So it is a beta function. Now we have our f of x is equals to this. Now we will find expectation of x raised to the power minus r. This is equals to integration. Now here f goes from the interval of f is greater than equals to 0 and less than infinity. So this is the interval for f. So we would have our e x raised to the power minus r. It would be 0 to infinity x raised to the power minus r into f of x into dx. So this would be, so now substituting f of x, we will get this is equals to integration 0 to infinity x raised to the power minus r into m by n raised to the power m by 2 divided by beta function, which is b m by 2 comma n by 2 into x raised to the power m by 2 minus 1 divided by 1 plus m by n x. This is raised to the power m plus n divided by 2 into dx. Now let us define a variable y which is equals to m by n x. Then we would have our dy is equals to m by n dx, or our dx would be equals to n by m dy, and our y would be equals to, and our x would be equals to n by m y. So substituting y is equals to m by n x, we would have this as integration again 0 to infinity, because when x would be 0, y would be 0. When x is equals to infinity, y would be infinity. So integration 0 to infinity. Now let's take m by n raised to the power m by 2 outside the integration sign. So here is m by n raised to the power m by 2 divided by b m by 2 comma n by 2. Now here we, instead of writing x, we will write n by m y raised to the power. Now here is m by 2 from this point minus r from here and minus 1. So it would be n by m y raised to the power m by 2 minus r minus 1 divided by 1 plus, as we can see that y is equals to m by n x, so it would be 1 plus y raised to the power m plus n divided by 2. Now in place of dx we would write n by m dy. So here it is this. Now this is equals to, now as we can see, this is m by n raised to the power m by 2 is actually n by m raised to the power minus m by 2. So if we take out this n by m raised to the power m by 2 minus r minus 1, so what we will have is n by m raised to the power minus r, as this m by 2 and this m by 2 will cancel out each other, and this would also cancel out each other. So what we would be left with is n by m raised to the power minus r divided by beta m by 2 comma n by 2. Now here we would have integration 0 to infinity y raised to the power m by 2 minus r minus 1 divided by 1 plus y raised to the power m by 2 minus r plus n by 2 plus r. Here what we are doing is we are adding and subtracting r so that the overall power remains same. Now this into dy. Now this part of integral will follow the following type. Now here we would use following integral formula, which is integration 0 to infinity x raised to the power mu minus 1 divided by 1 plus x raised to the power mu plus v into dx. This is equals to beta mu comma v. So using this function here, so here our u would be equals to m by 2 minus r, and our v would be equals to n by 2 plus r. So from here we would get, so this is equals to m by n raised to the power r divided by beta m by 2 comma n by 2 into beta m by 2 minus r comma n by 2 plus r. Now here our m should be greater than 2r. So our m should be greater than 2r. So this is expectation of x raised to the power minus r, which is equals to m by n raised to the power r into m by 2 minus r into n by 2 plus r divided by m by 2 and gamma function n by 2. So this sign, this is gamma function. So expectation of x raised to the power minus r is equals to m by n raised to the power r gamma m by 2 minus r gamma n by 2 plus r divided by gamma function m by 2 gamma function n by 2, where our m should be greater than 2r, or our r should be less than m by 2.